Hi, the title of our project is Representation Learning on Textual Edge Networks. Our team members include Shanxiu He, Weizhi Wang, and Zekun. So the first is our motivation. Edge textual networks are increasing prevalent in various domains, and edge in social information networks are usually associated with text information, such as user-user communications or user product reviews. And the key is to learn the contextualized edge text representation. However, most existing edge-aware graph neural networks are designed to handle categorical edge features. And some previous works also tried a straightforward node-centric idea to learn the free text features, and they obtained the text representation with pre-trained language model and then aggregate them to learn the node features, which process the text and the graph signal one after another. And we want to explore a way to better integrate the text and the graph signal. So our project is based on the paper at iClear 2023, titled Edge Formers, graph-empowered transformers for representation learning on textual edge networks. In this paper, they introduce two frameworks for edge and node representation learning separately. For edge representation learning, they inject the network information into each transformer layer when encoding edge text by adding virtual node tokens. And for node representation learning, they aggregate the edge representations through an attention mechanism within the nodes, each node's ego graph. And our goal is to understand the learned embedding space of nodes and edge. Besides, we also try to explore a unified framework for node and edge representation learning.
So for our project plan, for week 4 and 5, we want to first get familiar with the release code base. And then we want to reproduce the edge formal result on edge classification and link prediction task following the original paper. Next slide, please. And then for week 6 to 8, we have two possible directions to explore. The first one is we want to replace the current linear mapping of the virtual node representation with a structure-aware encoder, such as GNN. We also want to try unifying the process of representation learning for nodes and edges. And then for the final 2 weeks, we want to run the edge level and node level experiment with the new virtual node representation and with our unified representation learning scheme.
The third part is about the evaluation and the data sets we used. We will evaluate the proposed unified framework on 2 tasks. The first is the edge classification in the texture edge network, which contains a set of vertices, edges, and documents. Given the category of some edges in the training set, given an edge EIJ predicts its category Y based on the document IJ and the vertices IJ. We will evaluate our proposed network on the edge classification datasets of Amazon and Goodreads. The Amazon is a user item interaction network where reviews are treated as text on edges, and Goodreads is a read book network. We select the movie domain and application domain of Amazon and the crime and the children domain of Goodreads. We commonly use the classification metrics of macro and micro F1 score as the evaluation metrics. Please go to the next slide. And task 2 is about the link prediction, which is given 2 nodes in the test set Vi and Vj. You need to predict whether the edge EIJ exists in this whole texture edge network. We also evaluate the proposed network on Amazon and Goodreads. Also introduce another dataset of Stack Overflow. We will use the commonly used evaluation metric in the ranking framework, like the mean reciprocal rank and normalized discounted cumulative gain as the evaluation metrics. Thank you. This is the introduction to our project proposal.